In the topic of redox, sometimes it is handy to isolate a species and look at what's happening to it individually. And when you're doing this, a good way to do so is by using something called a half equation. To show what a half equation is, we're going to reverse engineer this process and start with the full equation. So for example, the zinc plus copper sulfate reaction we've been dealing with looks like this. What we can do to start off with is isolate the species that are actually changing. Get rid of anything that's not changing and only focus on things that are. To do this, we can generate something called an ionic equation. In an ionic equation, we get rid of sulfate in this case. Sulfate is a spectator ion. Nothing's really happening to it. It's going in as SO42- and coming out of the equation as SO42-, so we just get rid of it and focus on the things that do change, which in this case are zinc and copper. The next thing we do is we split this up into two half equations, one for zinc and one for copper. The zinc half equation tells you zinc's side of the story. It tells you what's happening to zinc. It's almost like a superhero movie. We start off with all the superheroes together, zinc and copper, and then you split them off into their individual stories, individual movies. So first we look at zinc's story and then we look at copper's story. When we look at zinc's story on its own, we have zinc's half equation. And in this case, we can see what's happening to it. When we are looking at a half equation, we need to make sure that charges on both sides are balanced. So for example, in zinc's half equation, zinc is 0 on one side and +2 on the other. That tells you that something's happening with electrons. Zinc in this case is losing electrons. It's giving up electrons. So what we do in this case is we write electrons as a product. There's got to be 2 electrons lost in order to give it a charge of 2+. In the same way, copper is starting off as 2+ but ending up as neutral. The only way this could happen is if copper was actually gaining 2 electrons as such. So we write electrons on the left side. Copper is coming together with 2 electrons, and when they join together, copper is now neutral. So in this way, zinc has electrons being released as a product, copper has electrons being gained as a reactant. And we have now written 2 half equations. We can take this a step further and label them as oxidation and reduction half equations. In zinc's case, zinc is releasing electrons, it's producing electrons, so this is a loss of electrons. And remember, oil rig, oxidation is loss of electrons. So because zinc is losing electrons, we call zinc's half equation the oxidation half equation. Copper, on the other hand, is gaining electrons. Reduction is gain of electrons. And because of this, we call copper's reaction the reduction half equation. When balancing a half equation, there are 4 rules, or 5 really, you need to follow. You start by balancing all the elements apart from hydrogen and oxygen. So if there are other elements present, you balance them first, make sure the amounts on each side are equal. You then proceed to balance the oxygens on both sides, but the way you do this is very unique. You do this by adding H2O to the appropriate side. So you don't actually balance it in the normal way by adding coefficients. Instead, you add H2O to whichever side needs more oxygens. The next thing you do is you balance your hydrogens, and again you do this in a very specific way. You add H+ to the appropriate side. A lot of redox reactions actually take place in acidic or basic conditions, and that's why we use H+. The next thing you do is you balance the charge. You balance charge by using electrons. What you've got to do here is look at the overall charge on the left side of the equation and the overall charge on the right side and make sure they are equal to each other. The way you do this is by using electrons. Electrons are negative and they'll bring the charge down. Now sometimes you may have to convert the conditions to basic conditions, and in such a case what you may have to do is add OHs, and in this case you add OH to both sides. The number of OHs you add is however many H pluses you've added in step 3. So the OHs combine with the H plus and neutralize them to form water, and then you'll have OH left behind on the opposite side. This is a bit beyond the scope of what we need to do in this course, but it might be something you want to practice for future courses in chemistry. Okay, so equipped with that knowledge, let's now try and balance 6 half equations. So we start with step 1. Balance all the elements that are not hydrogen and oxygen. In this case, that's sodium. question 1, by the way. In this case, sodium is balanced. There's 1 on each side, so we don't have to do that. Then we move to step 2. Step 2 is balance oxygens. There are no oxygens to worry about, so step 2 is done too. Moving further, step 3, balance hydrogens. There are no hydrogens to worry about either, so move on. Step 4 is balance charge by adding electrons. Now if you look at the charge, on the left side the charge is 0, on the right side the charge is +1. So we have to add electrons to bring the charge down. And the charge, if we add an electron on the right side, gets brought down to 0. In other words, they're equal. So there we go. This is our balanced equation. Now we can go take this a step further and work out whether this is oxidation or reduction as well. Because electrons in this case are being lost, we can call this an oxidation. In other words, sodium is being oxidized. Sodium is a reducing agent. Moving on to question 2, chlorine is Cl2 going to Cl-. We start with step 1, balance all the elements that are not hydrogen and oxygen. In this case, chlorine, the numbers aren't quite right. You need a 2 on the right side to balance the number of chlorines. Next thing, we balance hydrogens or oxygens. None of them are there, so we don't have to worry about step 2 and 3. We move straight to step 4, which is balance charge. The charge on the left side is 0 in this case, and the charge on the right is -2. Each chlorine is -1, but we have 2 chlorines, so it's -2. So we need electrons on the left side this time. Remember, the electrons bring the charge down. They make it more negative. And the number of electrons we need in this case are 2. So +2e-. And as a result, what happens? The charge on both sides ends up being -2. The charge doesn't have to be 0. It just has to be equal on both sides. And that's what we've done. In this case, the reaction involves a gain of electrons, so this is a reduction. In other words, Cl2 is an oxidizing agent. Moving on to question 3, iron becoming iron 3+. So we start with step 1. The number of iron ions are equal on each side, 1 of each. Next step, oxygen. Oxygen, there is none, so we don't have to worry about it. Step 3, hydrogen. No hydrogen, don't worry about it. Step 4, charge. So what do we have to do here to balance charge? The charge on the left is 2+, the charge on the right is 3+, so we add an electron on the right to bring the charge down. Now the charge on both sides will be 2+. And in this case, again, we've got an oxidation. Next up, we have a slightly weird example. Carbon going from 4+ to 4-. Step 1, balance carbon atoms. They're balanced. Step 2, oxygen, there is none. Step 3, hydrogen, there is none. Step 4, balance the charge. The charge on the left is 4+, the charge on the right is 4-. That is a difference of 8, technically. So what we're going to have to do is add electrons to bring the charge down. We're going to add them to the left, and we're going to add 8 electrons. And by adding 8 electrons, we make the charge on both sides -4. And this, once again, is a reduction. All right, now we get to 5 and 6, which are a little bit harder. Question 5, we start with the MNs. Balance the MNs. They are balanced. You've got 1 on each side. But then step 2, balance oxygens. This time we do have to actually do step 2. There are 4 oxygens on the left, none on the right. So what we're going to do is we're going to add 4 lots of H2O. I'm running out of space, so I'm going to write these underneath, but normally you write them side by side. Good idea to leave some space. So 4 H2O. Step 3, balance hydrogens. We've now thrown the hydrogens out of balance by adding the H2O, so we need hydrogens on the left side. And we balance hydrogens by adding H+. We're assuming acidic conditions. So H+ means we need 8 lots of hydrogen. Lastly, charge. Now, when you've got multiple things like this, it's a good idea to just stop and work out what the overall charge is at the moment. Overall charge on the right, nice and easy, it's 2+, right? On the left, however, you've got 8 H+, which means 8+ altogether, and MnO4 is -1. So 8 positives and 1 negative gives you 7 positive as an overall charge. So now you need to add electrons to bring that 7 positive down to 2 positive, to 2 plus. And so you add 5 electrons and you add them to the left, plus 5e minus. And then before we move on, what kind of reaction is this? The electrons are on the left, they're being gained, so this is a reduction as well. All right, lastly, Cr2O7 going to Cr3 plus. What do you do here? You start with step 1, balancing the chromiums, and in this case the chromiums are not balanced. You've got 2 on the left, 1 on the right, so you add a 2 in front of chromium. Step 2, balance oxygen, and you do that by adding H2O. So you go plus 7H2O. Numbers are going to get quite high in some of these cases. Step 3, balance the hydrogens. You balance the hydrogens by adding H+, and you need 14 lots of hydrogen on the left. And then finally, you balance your charge. And this gets quite tricky in this one in particular. I'm going to make some space. Okay, so on the right side, you have chromium 3 plus, and you've got 2 lots of chromium, so that is 6 plus overall, the charge on the right. On the left, however, each chromate, Cr2O7, is 2 negative, and you've got 14 positives from the hydrogen. So overall, your charge on the left is 12 positive. And so you need 6 electrons to bring the charge down to 6 plus on both sides. So what you do is you add 6 electrons on the left side, and that brings your charge down to 6 plus on both sides. And that is once again a reduction equation. The trick to doing this step is to do it step by step. Make sure you do each of them one by one, each step one by one. Make sure you don't skip any steps, and once you do that, you should hopefully get the correct outcome. The important thing to note about question 5 and 6 here, the permanganate and dichromate, they are useful chemical substances in this topic, and you will see them quite often. So just be aware of that. Now, to do more practice on this, which I advise you to do, pause the video and go off and do page 79, 80, 88, 91 to 95 in your workbooks, and then come back and continue the video. The last thing we're going to learn to do in this topic is to combine half equations together. When you're combining two half equations together, there are 3 simple steps you can follow. And the first is you need to make sure the number of electrons lost in one is equal to the number gained in the other. If not, you need to multiply one or both of them by the appropriate number. You then combine them, and you cross out like terms if they're on opposite sides. So if for example, you have H2O on the left and H2O on the right of the other reaction, you cross them out. If they're on the same side, you add them. And then finally, you write the 2 half equations together as a full equation, making sure that there are no electrons present in the final equation. So here we have 2 half equations ready to combine. We've got to follow these steps. Step 1, make sure the electrons are balanced on both sides. So for example, the first reaction has 2 electrons being lost, the second reaction has 2 electrons being gained, so they're good to go, nothing left to do. So then we combine them together, and we cross out like terms on opposite sides. And those like terms do include the electrons as well. You've got electrons on the right in the first equation and on the left in the second, so they can cross out, leaving no electrons behind. And when you combine them together, you get Mg plus 2H plus gives you Mg2 plus H2. If you know the states, it's really good to include them as well. Sometimes you don't, but as a rule of thumb, anything that's charged is probably in an aqueous solution. Metals like magnesium are normally solid, and of course H2 is a gas. There you go, that's a balanced redox equation. So now let's do some questions where we bring it all together. We'll split a full equation up into half equations, balance them out, and then bring them together. So for starters, we've got this as our question, iron and chlorine coming together. We've got to split them up into 2 half equations. So we've got our 2 half equations written out now. We've got to balance them to start off with. The first equation needs an electron on the right side to balance it, And then we get to the second one. The second one first needs chlorines to be balanced as so, and then we also need to balance charge by adding 2 electrons over there. There we go. Now we're done. Okay, so now we're going to combine these two equations together. But to combine them together, we've got to make sure our electrons are equal. And that's not the case currently. We've got 1 electron on the first and 2 in the second. So we've got to multiply the entirety of the first equation by 2. That will give us a 2 there, a 2 there, and change that to a 2 as well. And now finally we can combine them together. And when we combine them together, the electrons once again will cancel out. Everything else will be as is. So 2Fe2 plus Cl2 gives you 2Fe3 plus 2Cl minus. States again, we've got aqueous over there, gas, aqueous, and aqueous. So our final example of the day is also our hardest. We've got these two substances. Once again, follow the same steps. Try and pause the video and do it yourself. If not, I'll walk you through them in a sec. So these are our two half equations. I always try to write my half equations out, leaving a bit of space so I can add things in. So to start off with our first half equation, we need to add hydrogens. So step 1 and 2 are good. Oxygens are balanced, no other elements. So we move to hydrogens. And the way we balance hydrogens is by adding 2H plus on the right hand side. And if we do that, we now need to balance charge. And we do that by adding 2 electrons on the right hand side. Moving to equation number 2, manganese is balanced, so we move on to our waters, and we balance them by oxygen, by adding 4 waters on the right hand side. We then need hydrogen on the left hand side, and then we need electrons, and in this case we add 5 electrons on the left hand side. And now we come to the hard part. We need to multiply this by the appropriate numbers so that the electrons are equal. If that looks like it's hard to do, the easiest way to do it is to go to the lowest common multiple, in this case 10 electrons. So we're going to try and get up to 10 electrons in both of these equations. To do that in the first equation, we need to multiply it by 5. So this becomes 5, 5, and 2 becomes 10, 2 becomes 10. And then in the bottom, we've got to multiply this by 2. So 2 there, 8 becomes 16, 5 becomes 10, and then this is 2, and then we've got 8 lots of water. Alright, and then we start crossing things out. The first thing you should always do is cross out your electrons, because if they don't cross out, you know you've done something wrong, you've got to go back and do it anyway. Then you do anything else you can cross out. In this case, H+. There is H+ on the right side, and it can cross out some of the H+ on the left side. 6 to be specific. And that's it. That's all we can cross out. So now we combine whatever's left together. Write your equation sign as it is, and then bring everything down. 5H2O2 plus 2MnO4 minus plus 6H plus gives you 5O2 plus 2Mn2 plus and 8H2O. State symbols for these are a bit harder. H2O2 generally is aqueous, 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 gas, aqueous, and water is of course liquid. Okay, there we go. If you can do that question, you can do most questions. So what you should do now is pause this video, or stop this video entirely, and go off and do some practice questions from your activity books. The practice for this topic can be found on page 81 to 84 of your activity books. You can also find some on page 89. Be careful of the ones on 89. Some of the answers are wrong, and some of them ask you to do basic conditions. So maybe leave that as a last resort. And then 96 to 100. Have a go at practicing. Do as much practice as you can. Thanks for listening.